Okay, good day. So today we'll be talking about air supply. So for marine engineering. Okay, air supply. So objective, we have to focus on air supply, natural supply of combustion air, forced supply of combustion air, construction of the pressure filling unit. Okay, so natural supply. So in for engines with natural aspirated engine, so it has a natural supply sucked in by the piston. When the piston goes down, fresh air will enter into the combustion chamber during the intake stroke. So what kind of engine or principle of work can this work with? So only with 4-stroke engines. So as volume increases, pressure decreases. So why not in 2-stroke engine? Obviously because in 2-stroke engine, intake happens when the piston goes down. It is not the intake stroke, it is the power stroke. So there will be there is no way a natural suction of air will be or drawing in of air will be done in a 2-stroke engine, because as the piston goes down, it will be the power stroke to the exhaust stroke. Not like with the 4-stroke engine that there is a specific moment when the piston is going down and it is happening on the intake stroke. So also that natural supply can be done with that one. Next, for air supply in 2-stroke, so downward stroke is the power stroke for 2-stroke engine, and there the scavenge ports are air ports are at the bottom of the liner. So it is not applicable to have an downward stroke air supply, because the downward stroke is the power stroke for 2-stroke engines. Okay, so what are the different kinds of forced feed air supply? Okay, first, what is forced supply? So it is the putting a very large volume of air into the combustion chamber, so to force the supply of force the air supplied into the combustion chamber. So with which engines? So with all engines with turbochargers can do this one, forced feed, and for all engines with supercharger also, and for auxiliary blowers. So why do we have to do the forced feed? Of course, so forced feed, as you put a volume of air into the combustion chamber, you are also increasing the compression pressure during compression, and after the injection of fuel there will be combustion. So if you have quite a volume of air compressed and then create combustion after, so you will be creating very high power output after combustion. So that that high power output will be used in the maritime, in our marine engines, and in our ships. So we call this pressure filling. Okay, so we have to fill air inside the combustion chamber. So what forms do we know? So we have the turbocharger and we have the supercharger. So this one is the turbocharger, this one is the supercharger. Okay, so what forms do we know? So we have the turbocharger, we have supercharger, we have also the flushing piston. So flushing piston as the and then we have the auxiliary blower. Okay. Okay, so force feed. So this is a turbocharger. So how does this work? So if there is an exhaust from our engine, this exhaust will drive this turbine part of the turbocharger. This turbine will help, the exhaust will help rotate this turbine, and then after that the exhaust will go to the funnel. But since the compressor on the other side is connected to the turbine via this shaft, so if the turbine rotates, also that the compressor also rotates. So in the compressor side, fresh air from the engine room will be drawn in, and then it will be going to a charger cooler, and then going to the scavenge space, and going to the combustion chamber inside the engine. And then after it enters the combustion space, so the piston will compress that air, and then injection of fuel occurs, and then combustion occurs, and that exhaust of that combustion will go in here into the turbine. So that's it. That's how the turbocharger works. So turbos, how they work. So that's it. Okay, next. So for force feed like this one, we have here the exhaust. So exhaust from the engine goes here, turning the turbine and going to the funnel. On the other side, the compressor wheel will turn also, since this is connected to the turbine, and then this fresh air will go through a charger cooler and inside this intake manifold, and then entering into the engine after combustion. It will become an exhaust, and then going to the exhaust side of the turbocharger. So in this type of engine, we have a pulse type exhaust gas system. Pulse type, since there is a narrow tube creating pulsations or high pressure exhaust to our turbine to help it rotate faster. Next, we have the flushing. What is flushing? So flushing is the removal of unwanted gases, cleaning of the combustion chamber by using fresh air going to the combustion chamber and then flushing the exhaust out of the combustion chamber. So this inside here is the combustion chamber. So when does this happen? So this happen before the closing of exhaust valve and during opening of intake port or the fresh air. So flushing is the cleaning of the combustion chamber. During the flushing period, parts in the cylinder are also cooled. So these parts here are cooled, such as the valves. This is the exhaust valves, and the liner and the piston. So a 2-stroke and 4-stroke. This can be done for 2-stroke. So what flushing is also also called scavenging for 2-stroke, and for 4-stroke flushing is also known as a valve overlap. Okay, and as you can see, the holes in the inlet port of our so this is for the 2-stroke engine. So the inlet port is slightly angled. So the purpose is this one is to create a swirl so that there will be efficient entrance of air, and then the air will be distributed all over the combustion chamber, cooling all the parts and removing the unwanted gases. Okay, so there are different types of flushing. We have this one is the uniflow. This is the counterflow. Forgot this. I'm not sure with this. What's this? So this is the cross flow. This is the counterflow, if I'm not mistaken. Counterflow. We have the cross flow, and the best one is this one. We have the uniflow. This is the best one because the exhaust is usually the hot temperature exhaust gases will be at the top. So pushing it away at the top will be an easier way to clean the combustion chamber. But in this style of flushing, so the fresh air at the bottom will push the exhaust at that here on the upper part. But there is a chance that carbon deposits will be stuck in this part of the combustion chamber, thereby reducing the efficiency also for this one. So there are spots where there will be inefficient scavenging or flushing. Okay, we'll go to the turbocharger. There are two types of the turbocharger. We have the radial turbine and the compo axial turbine. Okay, so how can you let's check. So for axial turbine, as you can see, this is the compressor side and this is the turbine side for an axial turbine. So how does this work in axial? So the exhaust or the turbine in the turbine side, axial turbine, so the exhaust will enter actually, oh, this is the axial turbine, this one. Okay, so the exhaust will enter into the turbine actually, this one. It will go there in an axial way, and then it will help rotate this turbine, and then it will go out on a radial way. So axial entrance, so that is why it is an axial turbine. While for radial turbine, so the exhaust gas will enter in here radially into the blades, okay, and then moves out to the funnel. Okay, so this is radially, the exhaust enters into the turbine radially, so that's why it is called a radial turbine. So this will be the this is the compressor of a radial turbine turbocharger. Okay, so what are the components in the turbocharger? First, we have the inlet filter. So in this filter, fresh air will go inside the turbocharger, going to a filter to prevent any impurities, solid particles, or impurities that will enter into the turbocharger. Next, going to the silencer to prevent unnecessary noise during the intake of, or the inlet of air. Okay, after this one, it will go to the compressor. The compressor is the one that is sucking the air, and then going to a diffuser or a volute casing. Okay, then after that, it will go to a charger cooler and to the engine, and then it goes outside as an exhaust. So after, the exhaust will go here in our inlet exhaust gas casing, and then going to a nozzle ring. So nozzle ring converts pressure energy into kinetic energy, because this kinetic energy will be the one that will push this turbine to rotate. Okay, so after the turbine, it goes out to the diffuser or to the volute casing or the exhaust gas outlet, and then going to the funnel. So also here, if there is a nozzle ring in this part of the exhaust, in the turbine side, there is also somewhat like a nozzle ring in the compressor side. So it's not really been shown in here. So it's currently around here. So the purpose of this one is to convert the kinetic energy or kinetic energy air to pressure energy, because inside the engine, the air or pressurized air will be used to create a much stronger power for our combustion. So this is the inlet filter. This will be wrapped around the silencer. Okay, for cleaning compressor side, we have here a nozzle in here. So we usually do this at full speed. So connecting water to nozzle. So we put water in here, and then this water will be injected in a high pressure at the turbine blade. So that water will clean the turbine blade. So it is great to use water, since this part of the turbocharger is not hot. So you can use water in cleaning this one. So to be sure, you have to read the manual, so RTFM. So because in different ships have different ways of cleaning their compressor side. But normally, this is done once a day, especially at full speed. Okay, so during cleaning on the turbine side, so we can use water, and there is a drain in here. But using water for cleaning the turbine, you should not be running in full speed. So the engine should be running in slow ahead only. So slow speed, because too much at full speed, the turbine will be in high temperature, and injecting water will just create damage to the metal or to the material of our turbine, because water is has low temperature, and if the turbine is high temperature, there will be thermal shock damage to our turbine blades. Okay, so we can only clean it. We can only use water for cleaning the turbine side during slow ahead. You should fill the water tank, rinse until clean water from drain. So you should just fill this water tank, and this water will go here, injected into the turbine, and then the carbon deposit of the turbine will go with the water, and then the water will go down the drain. So you just repeat this one until the clean water goes out from the drain. Okay, so to be sure, just read that fucking manual, because in every ship there is different ways of doing this. So we usually do this once a week, but always check the manual. Okay, so what have we learned? So we learned that supercharge is and what it is used for. So supercharge, so we haven't discussed this one. We will go back. So as you can see, we have a turbocharger. Turbocharger is made run by an exhaust, right? But for supercharger, this is a separate blower. So this is connected to a motor via belt or coupled to a motor. So this one is superchargers are used to enhance or increase the air pressure entering into our combustion chamber. So this is motor driven. So separate that from the turbocharger. We have also flushing piston that will help to flush the air, compress it before entering into our combustion chamber. We have auxiliary blower that will help the engine during startup to have already air pressure inside the scavenge space. Even though the turbocharger is not yet running, there is auxiliary blower that will help support the turbocharger to give supply air to our scavenge space for combustion. That's it. Okay, so what types of supercharging exist? We have the auxiliary blower, we have supercharger, we have flushing piston. What types of flush are there? So there are the uniflow flushing, we have the cross flow flushing, and the counter flow, or what's that? Cross flow and cross flow, uniflow, cross flow, and counter flow. So what a turbocharger looks like, how to clean a turbocharger. So we have already learned this one. So that's it. Okay, so thank you for watching the video, and I'll see you on our next one. Goodbye.